Alright, good afternoon, Algebra 2 Trig Honors students. So today I would like to talk about the conic sections. So this one is one of the extension chapters, so it's not listed on the Big Idea textbook. So we want to talk about that. So started off with circle. If you guys do remember that circle, the equation of a circle is always written as x minus h quantity square plus the quantity of y minus k square. So that equals r square. So h comma k, it's always the center. And then r, it's always the radius of the circle. Okay, so let's say that we do have a circle. Let's see if I do have a mathematical compass here. 2. No, this one, it doesn't come along with okay, so let's just make it like this. So let's say we do have an x-axis, y-axis, and you want to make a circle. Okay. So again, radius, so this one r, and then we do have a point, x comma y. Okay, so anytime that you see the center, well, it's not always at 0, 0. It could be anywhere on the coordinate system. Could be in the first quadrant, second quadrant, the third quadrant. So anytime they want to find the vertices, so that means the endpoints on the circle, the one on the left, the one on the right, the one on the top and the bottom. So the radius is always considered r. Okay, like that. Okay, so now let's do the first example here. Okay, so let me put it out from the packet. Okay, so according to the packet, so we do have, well, number 2, negative 21 minus 4x plus x squared equals negative y squared. And for those you might be wondering, what do I need to do with the form like this? Okay, so we'll take a look at that. Okay, so the equation of a circle. Okay, copy and paste. Okay, so this one is considered negative 21 minus 4x plus x squared. So that equals negative y squared. So first thing that you want to do, you want to group those like terms. So that means you want to isolate a constant. Okay, so try to isolate the constant, or the constant term. So that means you want to give that negative 21 on the left hand side. So bring everything together except that negative 21. So we do have x squared minus 4x. And then plus y squared. So that equals 21. So what I did here, I add 21 both sides. And also at the same time, I add y squared. Okay, and then we group them, x group, and then the y group. And now for those you might be wondering, what do I need to do with this binomial? Well, this one, you want to complete the square. So the next step, complete the square. So the way to complete the square, again, it's b over 2 quantity squared. So it's negative 4 over 2 quantity squared. So then that'll be 4. So x squared minus 4x. So plus blank, add 4 here. And then on the other side right here, we also add the same number, 21 plus 4. Because now you want to balance the equation. And then the next step, you want to factor it. So once you factor it, would you have x minus 2 quantity squared plus y squared, so that equals 25. And now from here, and that would be considered the equation of a circle, compare and contrast. So x minus h quantity squared plus y minus k quantity squared, so that equals r squared. So that means h comma k, and that'll be considered 2 comma 0. And then the radius, then that'll be 5 for the equation of a circle. So now in terms of the graph, so how do you come up with the graph like this? So started with that 2 comma 0. So 2 comma 0. And we do know that the radius is 5. So count it, 5 units to the right. So 5 units to the right, so it's all the way to what, 7 here? Because 2 plus 5 would be 7. And then 5 unit up. And then 5 unit to the left. Okay, so negative positive 2, negative 2, right here, negative 3. And then 5 units down to the bottom. And then once you get all those vertices, guess what? Simply connect them. So it's a circle. If you have a compass, it's better for you to use a compass. If you don't, simply just draw the circle. Okay, so just like that. And now let's see what else. The other one, so identify the center, vertices, co-vertices, foci, length of the major axis, the length of the minor axis of each, then sketch the graph. Okay, so for that one, and let's talk about the equation of ellipse. Okay, let me go back to this slide here. So the equation of ellipse. So we do have two different type of ellipse. Okay, so equation of ellipse. Okay, so for the ellipses, we do have the vertical ellipse and the horizontal ellipse. Okay, so what that means, so again, h comma k is still considered the center. Okay, so h comma k for both of them, they always consider the center. And then for the vertices here, we do have the vertical major axis, so then that'll be h comma k plus minus a, and then h plus minus a comma k for the horizontal major axis. Okay, so for the vertices. And then the foci, so you see all the element here. So it's kind of visualize what's happening. So let me just draw the diagram here. And then let's just analyze the ellipse. So let's say we do have a vertical ellipse. Okay, so I need the x-axis and the y-axis. And let's compare that with the horizontal. Okay, so one is going this way. And the other one is going this way. So ellipse is kind of like an oval. It's like a football shape. Okay, so this one, let me just make it a little bit more symmetrical. Okay, let's see. Okay, so once again, this one, the one on the left-hand side, that's a vertical ellipse. And here's the horizontal one. Kind of like an egg or a football shape, okay? So here's the center, h comma k. Again, it's not always at the origin, okay? Sometimes it could be anywhere in the quadrant. First quadrant, second quadrant. So this one, the vertical ellipse. As you can see that the major axis, that would be the y-axis here. Okay, so this one would be considered h, comma, k plus b. And then here's another one. So h, comma, k minus b. So this one, it's called the main vertices. Okay, for both of them. And then the minor vertices would be the one right here. Or the co-vertices. The co-vertices. So this one would be considered h minus a, comma k. And then over here, h plus a, comma k. And now, the equation of the ellipse. So this one, if that's considered vertical, so it's always listed as x minus h quantity square over, well, this one would be considered over a square. And then plus the other one, y minus k quantity square over b square. So that equals 1. So this one is showing that b is greater than a. Okay, so b is greater than a. And the other one is quite similar. So this one, h comma k. So this one, h comma k plus b. And then over here, h comma k minus b. So this one is called the co-vertices. And for those who might be wondering why is this one called the co-vertice, because the distance of b here, it's smaller. And then over here, then that'll be considered h comma, well, h minus a, comma k, just like the other one. And then the other side here, h plus a, comma k. So this time, the distance of a, it's longer compared to b, so this one is basically the same equation. But the thing is that, excuse me, let me fix that. So this one's supposed to be y minus k quantity square over b square equals 1. So this one's showing that a is greater than b. Okay, so, and this one here, the whole, well, the distance from the vertex all the way down to this vertex here, this one is called the major axis. So the major. So the major axis for this one would be 2b. And the minor axis right here, then that would be considered 2a. So the minor axis. And this one similar, so the major axis, so then that would be what, 2a? Just the opposite. So from, well, the distance from one vertex to another vertex. So 2a. And then the minor axis would be this one, 2b. Okay, so going back to the formula chart. Okay, so this one, as you can see that, well, what they did here, they actually flipped the value of a and b. Okay, so this one, it's claiming that, well, a, it's always longer. It's always the longest distance. Okay, let's just follow through this, because the one that I show you, that was like an alternate form. Okay, so let's just flip that. So for the vertical, okay, so for the vertical one, we're saying that a is always the longest. So let me fix this one here real quick. So the vertical one, so this one we have to swap them. So always claiming that a is greater than b, okay, using that. So we can use the other form as well. So a is greater than b, so that means a is right here, and then b is over here. So it doesn't matter, both of them, that a is greater than b. So if a goes underneath that x square here, that means it's what? It's always the horizontal ellipse. Because that the major axis is right along the x-axis, or is parallel to the x-axis. And then if a, it's right underneath that y square, so that means it's considered the vertical ellipse. So that's how you differentiate them. Okay, so now let's do one example and see which one that is. Okay, so let's go back to the packet here. Okay, so we'll do number 4 this time. Okay, so we do have number 4, 0 equals negative 81 minus 9y squared minus 6x plus. Okay, so now first thing that you want to do, so you want to isolate the constant. Again, step 1. So isolate the constant term and regroup. Okay, so what we got here, if we try to isolate the constants, so we do have, well, if we try to take all the variables, the variable term to the left-hand side, we do have x squared plus 6x, negative to positive. And then the next one, we do have 9y squared minus 54y, and that equals 81. So the purpose of regrouping it, because you want to factor, you want to complete the factor for the, you want to complete the square for the next term, for the next step. So the next step here, you want to complete the square. So this one would be b over 2 quantity square. So 6 over 2 quantity square. So we do have 9. And then this one, before we complete the square, you probably want to take out 9 first. So we got y squared minus 6y. Okay. Plus a blank right here. So this one would be also, well, it's 6, but it's negative 6 over 2 quantity square. So it's 9. Step 3. Okay, so add the number. So add 9 for the first group here. And then for the other group here, for the y group, also you want to add 9. And then on the right hand side, so guess what you have to do on the right hand side? So this one you want to add 9. But for the second blank here, you want to add 81. Because the one that you're adding here, it's not just 9, it's the product of 9 and 9. So plus 81. Oh, never mind. This one is minus 81, negative 81, negative 81. Because that's a negative, so this one it's on the right hand side. So keep the exact same notation, negative 81. And then step 4, you want to factor it. So we do have x plus 3 quantity square, and then plus 9 times the quantity of y minus 3 square. So that equals 9. And then step 5, in order to convert this number to 1, so that means you want to divide everything by 9. Divide everything by 9. So we do have x plus 3 quantity square over 9. And then plus y minus 3 quantity square over 1. And that equals 1. So basically what this one is showing that it's a horizontal ellipse. Because the value of a, it's always greater than b. So a squared is greater than b squared right here. So a squared is 9, and then b squared is 1. So a is 3, and then b is 1. And then started with the center, so h comma k. So we do have negative 3 comma 3. Okay, so going back to the graph here, the graphing template. So negative 3 comma 3. So negative 3 comma 3, so it's all the way up here. And we do know that this one, it's a horizontal ellipse. Again, so it's x plus 3 quantity square over 9 plus y minus 3 quantity square over 1, so that equals 1. So a squared is 9, so that means a is 3. So b squared is 1, so that means b is 1. So count it, 3 unit to the right. So 1, 2, 3. And 3 unit to the left. And then for the minor axis, so it's 1 unit up. And it's 1 unit down. Connect those vertices, so that would be the ellipse. Now, we do know the vertices here, so this one is considered 0, 3, and then this one here, negative 6, 3. So for the vertices, and then for the co-vertices, that would be the one right here along the minor axis. So then that would be negative 3, 4. And then the other one here, negative 3, 2. And then what about the foci? So now you want to find out the value of c. So the way to find out the foci, going back to the equation, the formula. So the way to find the foci, it's consider h plus minus c, k. Okay, so h plus minus c, k. And the way to find out the value of c is by using kind of like a Pythagorean theorem here. So a squared equals b squared plus c squared. But it's actually the alternate form of the Pythagorean theorem. Okay, so we'll take a look at that. So a squared equals b squared plus c squared. So in order to solve for c, so that means is what? So c equals square root of a squared minus b squared. So we do have a squared minus b squared, so it's 9 minus 1. And then square root of the whole quantity. Then that'll be root 8. So the value of c is 2 root 2. Okay. So according to the formula, so the way to find out the foci, so the foci should be right along the major axis here. So we do have h plus c, k. So that means h here, which is what? Negative 3, and then k is 3. So that means it's negative 3 minus 2 root 2. Okay, foci. Negative 3 minus 2 root 2. And then for the value of k, just remains the same, 3. And the other one is negative 3 plus 2 root 2, comma 3. So minus 2 root 2, so somewhere right along that, the x-axis here. Okay, for the foci. And then the major axis, which is what? 2 times a. Okay, so the major axis, which is 2 times a, which is what? 2 times 3. 6. And then the minor axis, 2 times 1, 2 times b, which is 2. Alright? So for the ellipse. And now what about number 6? Number 6 is quite similar. So this one, according to what we know, a squared, it's always greater than, well, a is always greater than b. So this one, as you can see, that 49 is greater than 25. And 49, it's underneath that x squared, so it's another horizontal ellipse. So let's find out the center. So the center for this one, it's 0, comma, negative 2. And then the value of a squared is 49. So a is 7. If you take the square root both sides. And then b squared, it's 25. So that means b is 5. So started with the center, so 0, comma, negative 2. So 0, negative 2, right here on the y-axis. And then the major axis, so 7 units to the right. And then 7 units to the left. So that means the major the main vertices. So we do have 7, comma, negative 2. And then negative 7, comma, negative 2. And what about the co-vertices? Co-vertices from here. So count it 5 units up. So negative 2 plus 5, which is what? 3. And then count it down 5 units. So negative 2 plus minus 5. Then that would be negative 7. And then once you get all those points, label it. So this one, it's 0, comma, 3. And this one is 0, comma, negative 7. Well, because that you want to move 5 units all the way up, 5 units all the way down. Okay, center, so that's what, 0, comma, negative 2. And then simply just connect them. So this one is another horizontal ellipse. Okay, so just make it a little bit smooth if that's possible. Okay, let me just redraw this part right here. This one should be connected. Okay, so now what else do we need to find out? So we found the vertices, the main vertices, the co-vertices, and also we need to find out the major axis. So again, 2 times a, so 2 times 7, so 14. And then the minor axis, then that'll be 2 times b, then that'll be 2 times 5, then that'll be 10. And also we need to find out the value of c. Again, the way to find the value of c, so c equals square root of a squared minus b squared. So 49 minus 25, then that would be considered 24. Okay, so 49 minus 25. So 24, square of 24, then that would be considered 2 root 6. So again, right along the major axis. So for the foci, then that would be considered 2 root 6 minus negative 2, comma, negative 2. And then negative 2 root 6, negative 2. So 2 root 6, what is that about? So 2 root 6, that's about somewhere over here, right along the major axis. So let's find out what root 6 is. So that's right between root 4 and root 9. So this number, it's run between 2 and 3. So I would say that educated guess. It's like 2.4 something. So 2.4 times 2, then that would be considered 4.8. Okay, so that's somewhere right along the major axis. -2. And then also this one should be symmetrical. Okay, so for those foci. Okay, so make sure that you guys follow through the structure on the formula chart. Okay, so finding whether that's a horizontal ellipse or the vertical ellipse. Okay, so the formula chart, it shows you what you need to do. Alright, so that's it for this part of the video. And then next time we'll talk about something else, the hyperbola, parabola, and some other stuff. Alright, so I'll see you guys next time.